Hello everybody, this is our video solution to problem 9 from the final exam from fall 2020, Math 210. And this is about partial fractions. So there's a couple parts of this problem. The first part, we're given some nasty function, it's a rational function. Maybe the sort of thing that might show up, I don't know, maybe as a Laplace transform. And the question is simply asking us, which of the following is the correct partial fraction decomposition of f? So let's take a little peek and see which of these makes any sense as being the partial fraction decomposition. So let's see here. I know that when I go to break this up, that first, okay, there's this s term. So there better be something over s. Then I have an s plus 1 squared. So that's a repeated linear factor. So I'm going to need to have an s plus 1 as well as an s plus 1 squared. Then this piece, this is an irreducible quadratic. So I'm going to want to have this on the bottom. And on top, I know it's not just going to be a constant. All these should be some sort of constant. But here, I'm going to want it to be actually a linear function. So let's see if we violate any of these, right? Or if it's really easy to see that we can get rid of some of these. So probably the first one that jumps out at me is 9D here, right? Okay, or answer D, because, okay, I have, well, it's like this A could be 3/4, that would be fine. Then there's something over s plus 1, something over s plus 1 squared. But then it's not s squared plus 2s plus 4 down here. It's like been broken up into 3 different fractions, right? So this right here worries me quite a bit. There's just no way that's going to work, right? That's bad. So we're just getting rid of D. Okay. What else is different? Well, actually, a lot of these look very similar, right? So for example, here I have 3 over 4s, 3 over 4s. And, well, this is 3/4 over s, but that's the same as 3 over 4s. So there's no difference in that first component. What about an s plus 1? Well, here I have minus s plus 1 and or 1 over s plus 1 and minus 1 over s plus 1. Those are actually the same. And over here, now there is a difference. Okay, that's a difference. This one doesn't have the s plus 1 term, right? Now, maybe that's because b is equal to 0. Or maybe that's because it's wrong, right? That could be. So we might want to focus in on this one a little bit, right? If we can figure out what B is, that would be good. But let's look at the other ones. So there is a similarity here. So we have minus 2 over 3 s plus 1 squared. And over here, minus 2 over 3 s plus 1 squared. Okay, so those are exactly the same. Oh, and this one doesn't have an s plus 1 squared term. So maybe the C would be a good thing to look at. Okay, and then finally, well, let's see. These up here have the same, right? 1/4 s plus 1 6, 1/4 s plus 1 6, and that's just a 2/3. So this also might be something we could look at. All right, so we have lots of choices. Now, what would be a good one to start with? I recommend starting with the C. Why do we want to start with the C? Well, it's because this is one of the few coefficients we can get almost immediately by using what I call the thumb trick, or what's sometimes called the Heaviside trick or Heaviside formula, which is where, okay, we look at the highest power of a linear factor, so in this case, s plus 1 squared. I ask what would make this denominator 0, that'd be -1. And I just evaluate this thing at this f of s at -1, except, right, I cover up the s plus 1 squared, right? If I make s -1 there, I divide by 0. That's no bueno. So let's see what happens when I evaluate the remainder of this expression at -1. So let me start with the most complicated part, all right? If I put -1 into this quadratic, I get -1 squared is 1 minus 2, right? 2 times -1 plus 4. That's going to be 5 minus 2 is 3. This s is -1. So 3 times -1 is -3. And then here I have s plus 3. -1 plus 3 is 2. So I get 2 over negative 3. So it should be negative 2/3. And that is going to rule out b, because here it's not negative 2/3. In fact, it's 0, right? There is no s plus 1 squared. So we can rule out b. Okay, so we're down to just a and c. These were the same over s, so we're not worried about the a term. And they were the same, right, in the ds plus e, right, over the s squared plus 2s plus 4. Those are exactly the same. So what's the difference? This one doesn't have the b term, whereas this one does. So maybe we can figure out what the b term is. Okay, fine. Maybe the fastest way is to just write down what happens when we clear denominators. So let's see here. We would get, maybe we'll move, yeah, we can do it over here. So we have s plus 3 is going to equal, all right, so we multiply everything by the denominator. Now we know what the a is already, right? There's only two options over here left, and both of them, the a is 3 over 4. So we get 3 over 4, right, or 3/4. Let's see, oh, right, we're clearing denominators. So when we clear denominators, I'm left with, let's see, the s cancels, and I'll have s plus 1 squared, and then times s squared plus 2s plus 4. Okay, then we go to the next term, right? That has the b. And the b, that's the thing we want, so we don't know what that is yet. But when I clear denominators, let's see, I get an s. I'm multiplying by s plus 1 squared, and I get rid of one of those. So I still have an s plus 1, and then I have an s squared plus 2s plus 4. The c we established was minus 2/3, and when I clear denominators, I get an s. The s plus 1 squareds cancel, and then times s squared plus 2s plus 4. And then, okay, I don't know the ds plus e. Oh, wait, yes, I do. It's this bit over here, 1/4 s plus 1/6 times, okay, I clear denominators, the quadratics go away, and I'm multiplying by s times the quantity s plus 1 squared. Okay, so we're adding that. And I care about the b. So is there anything I can do that's maybe unique for finding the b? Well, let's see here. The highest degree term, that's either the highest or the lowest is usually nice to look for. And so let me see here. How many highest degree terms can I get? So let's see. The highest degree here, I would get s squared times s squared. That's s to the 4th. Okay, and here a b I can get s to the 4th because I have s times s squared. Okay, so I have 0 s to the 4ths on the left, and then on the right I have 3/4. I have b times all of these, so plus b. Here I don't get an s to the 4th in this one. The highest is s cubed. And then here I can get an s to the 4th because I can do a 4th s times s squared. So that would be another 1/4 s to the 4th. So 3/4 plus 1/4 is equal to 1. So this is equal to 1 plus b, and so b is equal to -1. All right, well, which one is my -1? Well, over here I had no b, I had a 0b. This one is the -1, and so that is my answer. Whew, that felt a lot harder than I would expect for a multiple choice problem. All right, well, let's look at part B now. Here, they say a friend is performing a partial fraction decomposition and has gotten to this following point. Oh, wow, so we don't even know what the original problem was. But we're going to try to find A, B, and C anyway. All right, well, let's take a peek. So I can see if I started distributing, I'd be able to get an s squared and an s squared as the highest terms. All right, so let me start with my s squareds. So let's see. On the left, I have no s squareds. On the right, I would get a times s squared and, well, b times s squared, right? bs times s. So a plus b is going to be 0, which tells me that b is going to be the opposite of a. All right, how about the s's? Well, let's see. I have 5 s's on the left. On the right, I have a times 3s, so 3 a's. And then, oh boy, okay, we got some interesting stuff going on. I have bs times -2. So that's going to be -2 b's. But I also have C times S, so plus C. Now I can simplify this because I know B is negative A. So if I replace B here with negative A, I have 3A minus is plus 2A. So that's 5A plus C, which tells me that C is going to equal 5 minus 5A. All right, so I still know everything in terms of A. Well, let me check the constants now. So I have no constant on the left, and on the right I would get A times 4. And then I could also get, well, let's see, B already has an S on it, so the only constant I can get is C times negative 2. So 4A minus 2C. But I know that C is equal to 5 minus 5A. And I'm going to multiply that by negative 2. So let's see, I have 4A. Then let's see, how many other A's? I have minus 2 times minus 5A. That's going to be plus 10A. And then minus 2 times 5 is minus 10. If I combine this, I have 14A minus 10. And so, since I know this is equal to 0, 14A is equal to 10. And dividing by 14, we get A is equal to 10 over 14, or if we prefer, 5 over 7. And so now I know that my B, which is negative A, we had that up above, is going to equal negative 5 over 7. Also, my C, which is equal to 5 minus 5A, is going to be 5 minus 5 times 5 over 7. All right, let's see, that's going to be 25 over 7. 5 I could write as 35 over 7. 35 over 7 minus 25 over 7 is 10 over 7. And so now we found A is 5/7, B is negative 5/7, and T is 10 over 7.